From electrification to hydrogen, from cleaner fuels to sustainable raw materials for everyday products. Welcome to the Energy Transition Campus in Amsterdam. Here, innovators come together to develop energy solutions for today and tomorrow. In 2022, Shell transformed its former technology center into an open innovation campus, recognizing that a single company can't tackle the energy transition alone. That's why collaboration is at the heart of the campus. Startups, established companies, governments, and universities work side by side to bring new ideas to the market. It started in 1914 with a small Shell lab in Amsterdam Noord with a staff of 9. Today, hundreds of bright minds collaborate at a world-class innovation campus spanning the size of 13 football fields with cutting-edge labs, workshops, and offices. Underground thermal storage and heat pumps keep the building comfortable year-round while keeping its carbon footprint as low as possible. The campus runs on renewable energy, from wind power from the North Sea to solar panels on the roof. The solar panels are part of a smart microgrid, a flexible energy system that manages energy generation, energy storage, and energy use across the campus. The microgrid connects 110 EV chargers, batteries, and research equipment, giving researchers a living lab for energy management solutions. By intelligently balancing supply and demand, the microgrid helps to enable electrification-driven research and overcoming grid constraints, a common challenge in the energy transition. The microgrid also powers Shell's first megawatt charger for ships and trucks, an exciting step towards electrifying heavy-duty transport. Simply put, a bigger charger means faster charging. This advanced system includes a rotable arm for electric vessels, an overhead setup for trucks and buses. A variety of connectors makes the supercharger compatible with a wide range of vehicles, vessels, and battery types. Another route to decarbonize transport is through sustainable fuels. At ETCA, researchers explore different ways to create sustainable fuels like biofuels and synthetic fuels. Biofuels research focuses on diesel and kerosene from vegetable oils such as sunflower oil. Even used cooking fat from ETCA's kitchen is used for experiments. Synthetic fuels are made from CO2, water, and renewable electricity, based on the gas-to-liquids process, or GTL. Shell has been advancing the GTL technology here since the 70s, originally developed to turn natural gas into cleaner burning fuels and lubricants. GTL has become a versatile process at the basis of sustainable alternatives to fossil fuels. In early 2021, Shell researchers used the GTL process as a fundament in producing the first 500 litres of aviation kerosene based on CO2, water, and renewable energy. A KLM passenger plane flew on a mixture with this fuel, a first for the world. Besides synthetic kerosene, the first synthetic methane is made in the GTL pilot plant at ETCA. Synthetic methane is a cleaner gas made by using renewable energy. Researchers are testing different ways to make it, including electrochemical methods. This helps develop sustainable alternatives to liquefy natural gas and supports cleaner transport. Many of the technologies developed at ETCA rely on chemical reactions, and catalysts play a key role. Catalysts speed up reactions and can make processes more energy efficient, which is essential for scaling sustainable solutions. New catalysts can boost hydrogen production, delivering more hydrogen with the same amount of energy. Hydrogen can play a key role in the energy transition, for example, to power industries or to decarbonize heavy-duty transport. The hydrogen cluster works on how to produce, transport, and use hydrogen while de-risking new technologies for wider use. One way to do this is the on-site production of green hydrogen using an electrolyzer powered by solar panels on the roof. The electrolyzer splits water into hydrogen and oxygen using renewable electricity. The green hydrogen is used in research installations, and the lessons learned helped shape the design of Europe's largest hydrogen plant in Rotterdam. Another example of labs research turning into real-world impact is ETCA's work on circular plastics. Until recently, most plastics could only be recycled mechanically, a method that doesn't work for all types. In 2019, ETCA began developing chemical recycling to give hard-to-recycle plastics like food packaging a second life. After successful lab testing and pilot trials, the process was scaled up, leading to the opening of a new chemical recycling plant in Moerdijk in 2024, capable of processing up to 50,000 tons of plastic-derived oil per year. Sustainable energy solutions are increasingly important, but we can't manage entirely without fossil fuels yet. At ETCA, the Rocks and Fluids Lab studies the qualities and characteristics of various types of oil, natural gas, and rocks. These laboratories also support energy transition projects, such as carbon capture and hydrogen storage. Most of ETCA's 1,300 testing installations and pilot plants are designed, built, and maintained in-house, making the campus truly unique. Mechanical engineers combine traditional techniques with cutting-edge tools, from glassblowing to state-of-the-art 3D printers for plastics and metals. It's a blend of craftsmanship and innovation that powers progress. ETCA's first 3D printer arrived in 2012, revolutionizing how researchers build prototypes. It allows for an on-demand production of complex metal and plastic parts, using less material and time than traditional methods. Today, even the most complicated components for pilot plants and full-scale factories can be printed right here on campus. ETCA houses a cluster of companies working on digital technologies that support the energy transition. One example is the digital twin of the electrolyzer, which simulates the real installation and allows researchers to test and improve it in real time. Other digital tools include drones and robots that safely inspect factories and AI systems that detect and prevent malfunctions. These technologies reduce downtime, improve safety, and lower energy use by keeping operations stable and efficient. We hope this virtual tour has given you a glimpse into the research activities on our campus. Our innovations may not always be visible to the public, but they all play a vital role in meeting the energy needs of today and tomorrow.